Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS8602, Compiler Design, Unit 4, Topic, Storage Organization Stack Allocation Space. Storage Organization, the management and organization of this logical address space is shared between the compiler, operating system and target machine. Here the operating system maps the logical addresses into physical addresses which are usually spread throughout memory. Here the runtime representation of an object program in the logical address space consists of data and program. Here the compiler for a language like C++ on an operating system like Linux might subdivided memory as shown in the figure. That means here you have code, static, heap, free memory and stack. First we are going to see the code memory. That means it is the size of the generated code that is fixed at compile time. So the compiler places the executable target code in a statically determined area. It is also the low end of memory. The next one is stack area. It represents the size of some program data object such as global constants and data generated by the compiler such as information to support a garbage collection may be known at the compile time. The next one is stack and heap area. Using this you can able to maximize the utilization of space at runtime. The other two areas stack and heap are at the opposite ends of the remainder of the address space. The next one is stack area. It is used to store data structures called activation records that get generated during procedure calls. Activation record means it is used to store information about the status of the machine such as the value of the program counter and machine end registers when a procedure call occurs. The next one is heap area. Many programming languages allow the programmer to allocate and deallocate data under program control. For example, C has the functions malloc and free that can be used to obtain and give back arbitrary chunk of storage. It is used to manage this kind of long-lived data. Then next we are going to see the stack allocation space. That means each time a procedure is called, space for its local variables is pushed onto a stack, and when the procedure terminates, that space is popped onto the stack. This arrangement not only allows space to be shared by procedure calls whose durations do not overlap in time, but it allows us to compile code for a procedure in such a way that the relative address of its non-local variables are always same. It is also the regardless of the sequence of procedure calls. The next one is the activation trees. Stack allocation would not be feasible if procedure calls or activations of procedures did not nest in time. Next, we are going to see the activation record. Using this, the procedure calls and returns are usually managed by a runtime stack called the control stack. Here, each live activation has an activation record, and also sometimes it is called as a frame on the control stack, with the root of the activation tree at the bottom and the entire sequence of activation records on the stack corresponding to the path in the activation tree to the activation where control currently resides. The later activation has its record at the top of the stack. In this diagram, it shows actual parameters, return value, control link, access link, saved machine status, local data and temporaries. First, we are going to see the temporary values. Here it used to arising from the evaluation of expression in case where those temporaries cannot be held in registers. Here the next one is local data belonging to the procedure whose activation record this, and a saved machine status with information about the state of the machine just before the call to the procedure. Then the access link may be need to locate data needed by the called procedure but found elsewhere. For example, in another activation record. Here the control link pointing to the activation record of the caller. The next we are going to see the calling sequences. Procedure calls are implemented by what are known as calling sequences, which consists of code that allocates an activation record on the stack and enters information into its field. A return sequence is similar code to restore the state of the machine so the calling procedure can continue its execution after the call. In this diagram, it shows the parameters and return value how with the called upper from one level to the next level. The next we are going to see the variable length data on the stack. In this diagram it shows the runtime memory management system must deal with objects whose size are not known at compile time. In modern languages, objects whose size cannot be determined at compile time are allocated space in the heap. It is also possible to allocate objects, arrays or other data structures of unknown size on the stack. Thank you.